All right, welcome to week 2, you guys. Hopefully week 1 went well. Thanks for turning things in. It looks like things are going pretty well. We're going to go into 12.4 law of sines. This traditionally tends to be the most challenging for students just because there is an ambiguous case with side-side angle, which you might have remembered from geometry talking about a little bit last year, but we'll get into that later. So the first step we're going to look at is finding area of a triangle, and most of you guys know on area of a triangle, simple. When we talk about area of a triangle, you're probably very familiar with the area equals 1/2 base times height formula, and that's the one that was kind of drilled into your heads years ago. All right, but if we take any triangle, what we're going to do is we're going to make this more specific to our trig values. Okay, so if I were to highlight this triangle and I were to take this right triangle, it's in red now, okay? And I look at angle A, I know that the height is actually my opposite side, and I know the hypotenuse is this C value in my triangle, okay? So the question is, when I set up these values, I know the sine of A, and this is just our standard trig ratios we took from section 12.1. So we have the sine of A equals opposite over hypotenuse, which in this case is H over C. Again, so what we're doing is we're taking our very known formula for area of a triangle, and we're going to modify it specifically to trig values. So we actually don't need the base and the height. Okay? So if I take the equation we just set up based on our red triangle, if I multiply both sides by C, I know the height of my triangle is C times the sine of angle A. And we actually know how to calculate that at this point. Okay? So now I can just substitute this in, A times BC times the sine of A, all right? And that's my new formula. And if you look at it, what we need is we need the base, we need the hypotenuse, and then the angle we actually need, BC, and then angle A. This works for side angle side cases, okay? So if I have side angle side in a triangle, I actually don't have to figure out the base or height. I can use this formula to figure things out. I'll zoom back out for you so you can get a chance to type these in or write these down if need be. But notice they're all specific, and if you are using that formula sheet, they're on the formula sheet as well. So if I'm looking to find the area in example 1 of triangle ABC, even though it's not a right triangle, I can still figure out the area using my formula. So I have 1/2, and then I take the product of the two sides, and then it's always going to be sine of the interior angle. Okay, so we have 1/2 times 9 times 8 times the sine of 104. Again, make sure you guys, when you type this in your calculator, that your calculator is in fact in degree mode, and then you should wind up with 34.9 square centimeters. And that's how we can find area of a triangle given two sides and in the included angle. That's going to be the first part of your day, all right? The second part of the day is based on law of sines. And you guys talked about this last year in class, but law of sines is based on the same idea. So what I can do is I can take any triangle, any triangle, it doesn't have to be right, and I can break it up into two smaller triangles, two smaller right triangles. And the idea is that if I'm looking at my blue triangle, if I take the sine of A, that's going to be the height over C. In my red triangle, the sine of C is going to be, again, this height over the hypotenuse. And if I rearrange these, multiplying both sides by A, or in the blue case, multiplying both by C, those drop. And then we have C times sine of A equals A times the sine of C. And that looks really great because they both equal H. But what I actually can do is rearrange it. And if I divide both sides by CA, then I wind up with the sine of A over A equals the sine of C over C. And that is, in fact, the law of sines. I'm guessing in the past, if you have used this at all, you've probably just seen the formula, but you haven't actually maybe figured out where it's come from. Well, it's come from the same idea as your right triangle trig we talked about in 12.1. So again, law of sines is derived from your right triangle trig in section 12.1. Okay? Law of sines, just so you know if you want to write this down, super effective when you have two angles and a side, or if you have two sides and an angle. The one stipulation is the side and angle have to be opposite each other. Okay? Otherwise, it's not going to work. We're going to delve into a few problems here using law of sines. Okay? So, first and foremost, I would encourage you to draw a sketch just to kind of get a picture in your mind of what things look like. It doesn't have to be perfect and it doesn't have to be to scale. Okay? So if I just say this is angle B, and then this is angle C, and then that would mean C is across from it. This would be B, that's angle A, and that's side length A. So again, when we label triangles, we always label angles and sides opposite each other. Well, in this situation, when we're given two angles, this is probably the easiest thing to start because it's super simple to figure out angle A, because you know that three angles in a triangle must add up to 180 degrees. So the question is 180 minus 80 is 100, minus 45 is 55 degrees. All right? At this point, then we can set up law of sines. So we have sine of A, which is 55 degrees. Back that up. Okay, so again, the sine of 55 we know now over A. We have the sine of 45 over B, and then we have the sine of 80 over C, which in this case is 3. So then all we have to do is actually cross multiply to solve. So if I'm going to cross multiply here to solve for B, I'm going to take 3 times the sine of 45 and then divide it by the sine of 80. And we're going to find that B equals 2.2. Okay? Remember, again, you want to use your calculator, make sure it's in degree mode, and then continue on from there. So we switch our ratio. Make sure we don't use B because this was a rounded value. So we want to go back to our original one we know and compare it to A. Again, we're going to cross multiply. So we do 3 sine of 55, divide it. Making a video.
What?
Making a video for class. Yep.
You're a math teacher, right?
Yep.
Oh,
High
I
school.
thought so, yeah.
Yep. No, you're fine. So we do 3 sine of 55 divided by the sine of 80. And then we wind up with A is 2.5. Okay? After we figured out the 3 pieces of information, we're done. All right? And that's how we solve a right triangle. Again, this is probably the easiest scenario where you're given 2 angles. All right? Next problem we're going to go into. Again, same idea. Very first step, sketch. It doesn't have to be perfect, but type in what you know. So we know A is here, we know B is 12, and we know C is 68. B is up here, little a, little c. So again, same thing, we're given 2 angles, so what we do, 180 minus 68 minus 50, and we wind up with B is 62 degrees. Again, all 3 angles in a triangle must add up to 180. So again, that's probably the easiest step. At that point, we can set up law of sines. So we have sine of 62 over 12 equals the sine of 50 over A, still unknown, equals the sine of 68 over C. Again, we're just going to go ahead and cross multiply to solve. So we do 12 times the sine of 50 divided by 62, just simple work with cross multiplying and proportions in that case. Again, make sure your calculator's in degree mode. When we do 12 sine of 50 divided by 62, we get A is 10.4. Continuing on, make sure you use the original. Do not use the number you just found, because that 10.4 we rounded, okay? So do not use a rounded value to find another value in your equation. It's not going to work, okay? You're going to end up with some rounding error. So we want to use our original ratio we have. So we do 12 sine of 68. Then we divide that by 62, and we get C is 12.6. All right. Sorry about that interruption again. We have one last page of things, and this is probably the most confusing for people, but please don't let it be. All right. Looking at this very last step, there's this big table. You can look over it. We'll kind of talk it through time to time, but our side-side angle case is the one we have to worry about, okay? Sometimes there's triangles and sometimes there isn't, okay? I'm going to try and help as much as I can in this case. I also have another 12.5 lesson video which further clarifies laws of sines that I used last year, and I'll throw that online as well so you can kind of take a peek at things. But this is the hardest concept for people, not using law of sines, but figuring out how many triangles actually exist. Again, the only time we have to worry about it is with the side-side angle case. Otherwise, everything is A-okay. So, first things first, draw a sketch. We have A is 95 degrees, the side opposite A is 10, and then we're just going to say this is 12. And again, keep in mind our pictures aren't going to be to scale. But if you look at this, does it make sense that I have an obtuse angle and the side opposite my obtuse angle is smaller than the adjacent side? Hopefully that's sending up some red flags. If that's my largest angle in a triangle, that should be my largest side. And if you look at the 6 cases above, it actually coincides with this one, okay? Our angle is obtuse, and then the opposite side is actually bigger than the adjacent side, okay? In this case, no such triangle can exist, so I could stop right there. I don't even have to use law of sines because I know I'm done, okay? In some situations where we have the side-side angle case, we might have a triangle that exists, and that's part B, all right? So I'm going to draw in my triangle here. B is 32 degrees, side length B is 7, and then the adjacent side is 4, okay? And the question here is, well, how many triangles exist in this case? Well, if I have an acute angle, it makes sense that our opposite side could be bigger than the adjacent, and that actually coincides right here with this one, all right? So when we have an acute angle and the opposite side is bigger than the adjacent, all right, there is going to be one triangle. As I'm looking at my notes back here, I drew my sign wrong. The opposite side was smaller than the adjacent. I apologize for that. Okay, so part A, the opposite side was smaller than the adjacent side, so there was no triangle. Okay, on example 3B, coming back to it, the opposite side is bigger than the adjacent side, so you know what, that's awesome, that can happen, that's A-okay. We're going to have one triangle in this case. Then we just go through law of sines like normal to figure things out. So I do sine of 32 over 7 equals sine of C over 4 equals sine of A over A. Okay, then as we're doing law of sines, just like we said before, we're going to cross multiply. So 4 times the sine of 32. We're going to divide by 7, but in this case, since I'm looking for an angle, I'm going to do sine inverse. So it's the sine inverse of 4 times the sine of 32 divided by 7, and you wind up with C is approximately 18 degrees. Okay? Again, I'm using rounded values here. but please use those stored values in your calculator. At this point, the only time you want to round is when we're writing an answer down. That way you don't have to write your decimal with 9 places. But make sure, typically we'll do side lengths to the nearest tenth and angle measures to the nearest degree, but just be mindful of things. At this point on B, we have 2 angles, so now I can figure out the third angle. 18 and 32, if you look, 32 and 18 is 50 degrees. So A must be 130 degrees. So then you can go up to your problem, plug in 130. Again, use the original ratio. Don't use the one with 18 unless you're using that calculator stored value. But we do 7 times the sine of 130 divided by the sine of 32. And then we're going to take the sine inverse of that value, and we wind up with 10.1. All right? So that's the one triangle case. All right? Last but not least, and finally, you guessed it, we're going to get into the 2 triangle case now. And actually, I want to leave that picture there for just a second, and then we'll slide over. But we have 47, we have 15, so again, that's angle A. B is 18, okay? This is the time where we have to really keep in mind. So just like our obtuse angle, when the opposite side's smaller than the adjacent, we want to be mindful of that. So what we're actually going to do is we're going to calculate this imaginary value. Okay, it's the height. So how we do that is we do 18 times the sine of 47. And in this case, we find out it's 13.2. And it's always going to be the adjacent times the sine of the angle. Okay? And when you get this value, if it's smaller than the opposite side, there is 2 triangles. And that's this situation up here. Okay? If it equals the opposite side, there's 1 triangle and it's right. If that value is smaller, there's actually no triangles. Okay? And just kind of be mindful of that as we go through things. If the opposite side's bigger, calculate the would-be height. And if it's smaller, we have problems. If it's bigger, then it's okay. All right? And then, once we establish there's 2 triangles, we just go through everything just like we normally would. So we take our sine of 47 over 15 equals the sine of B over 18 equals the sine of C over C. Okay? Keep in mind, as we move forward, we know there is going to be 2 triangles. So when I do this very first ratio, this is where I need to take into account my 2 triangles. So I do 18 sine of 47 and divide by 15. I do the sine inverse. And I wind up with B is about 61 degrees. Okay? Immediately you want to stop right there and figure out B in your second triangle. And it's super easy, you guys. All you do is take the supplement of this. So the question is, what's 180 minus 61? Well, that's 119 degrees. So again, these 2 angles will be supplements of each other all the time. The rest of the information you just have to go through and complete like normal. Okay, so if I have a triangle that has a 47 degree angle and a 61 degree angle, I know the third angle must be 72 degrees because they have to add up to 180. If I have a triangle that has 119 degree angle and again an angle of 47 degrees, I know my last angle has to be 14 degrees because they always add up to 180. Then you can just do law of sines that last time to figure things out. And we're going to compare it back to the original, but keep in mind we're using our new C values and different C values. When I use 72 degrees, I get this side length is 19.5. And when I use 14 degrees, I get C is only 5.1. Again, this is probably the most confusing part for people. I will post a second video regarding this information online. And if you do have questions, please utilize the discussion board throughout the day. But there's your homework. There's your assignment for the day. Let me know if you have any questions. Best of luck.